So in this today's lecture, we are going to see Unit 5 of Intelligent Transportation System. So in this unit, we are going to see what is the ITS application, in which we are going to see what is Traffic and Incident Management System, ITS and Sustainable Mobility. Then we are going to see the Travel Demand Management, what is Electronic Toll Collection, ITS and Road Pricing. Then we'll be moving towards the Transportation Network Operation, Commercial Vehicle Operation, Public Transportation Applications, followed by Automated Highway Operations, Vehicles in Platoons, there in which we are going to see the ITS in the world. Then we are going to see what is the overview of ITS application in the developing countries and in the developing countries. So coming to the introduction of ITS application, the Intelligent Transportation System so basically refers to the practical use of advanced information, communication, sensing and control technologies which is helpful for improving the performance of the transportation system. So this ITS application support efficient traffic management, it enhances the safety, promotes sustainable mobility and improve public transportation services and enable effective pricing and demand management strategies. So in this ITS, we are going to see how we are going to practically apply this ITS for the various traffic operations, for which it can enhance the safety, promote the sustainable mobility, for the effective pricing, and how can it meet the demands of and the strategies. So these are the three things, the parameters which are correlated with each other: the people who are using the vehicles and the vehicles which are applying onto the roads. So this is a information and communication technologies go hand in hand. Traffic management system. So let us see what is TMS. So the traffic management systems are basically the applications of ITS which are designed to monitor, control and optimize the traffic flow on the road networks. So basically these types of system uses the real-time data which we are collecting from the sensors, camera and connected vehicles to support the traffic control decision. So in this basically the TMC, the video recorders or the cameras are being placed onto the road, from which these are nothing but the sensors or the cameras from which we are taking the live data or the real-time data to find out what is the traffic over there and to give the control decisions of the traffic. So TMS is basically a type of a system which is basically designed to monitor, control and optimize the flow of traffic on the urban arterials. So what are the key functions of TMS? So it is nothing but we are getting the real-time traffic monitoring and we are able to do the real-time surveillance. The adaptive signal control, we are able to control what is a signal at the junction or an intersection. We are able to find out what is a congestion, so we can detect the congestion and what are the primitive or mitigation measures that we are going to see from this TMS. Traffic information dissemination to the urban users. So how the traffic is being distributed to the different routes can be predicted to the road users. And the coordination with emergency and enforcement agencies. So in case of any incident or an accident on the road, we can control or we can give some sort of warning to the emergency and the enforcement agencies such that they can reach at that location for proper treatment. So this TMS basically helps us to reduce the travel time, the congestion, the fuel consumption and the emissions, because the emissions are very high coming from the petrol and the diesel vehicles, and the pollutants are very harmful to the humans. So this TMS basically helps in improving the road safety. So this is how the TMC works, where the information is being circulated from different parameters. So here we can see that a vehicle is being transmitting the information to other modes of vehicle. So here a connection is being built between V to V, that is vehicle to vehicle, V to I, vehicle to infrastructure, and if suppose the pedestrians are walking onto the road, it is also developing a connection between V to P, which is vehicle to pedestrian. So that is how the ITS helps us to ensure the smooth flow of travel on the roads. So basically these are ITS are the advanced applications with and without embodying the intelligence, such as it aims to provide innovative services which is helpful for different modes of transport, So since our India is an heterogeneous traffic where different type of traffic prevails on the road, so we can see the two-wheeler, three-wheeler, bus, car, trucks, and everything same share the same path of the road. So that is why innovative services are very much required, wherein which we are getting the things or the applications from this ITS. And the traffic management allows the various users for the better informed, and it basically help for safer, more coordinated and smarter way use of the transportation networks. So this is what we have discussed, like it is able to build the connection between different types of vehicle. It is not only one type of vehicle, it can be it is developing between different modes of the vehicle. As we can see from the picture, like it is building a connection between a private car to the public transportation, so in order to ensure the smooth flow of travel on the roads. So basically this is how the TMC look like, where huge amount of where huge cycles, or we can say that huge amount of monitors has been installed on the like on a center, where different screens has been placed over it, and we are able to see whether how smooth of the flow of the traffic is there, whether is any congestion is there or not, how the vehicle is moving, whether the vehicle is moving in a proper lane discipline or not, whether any violation is happening or not, whether any incident are happening or not, how the smooth flow of traffic, everything we can monitor by sitting at the TMC, which is the traffic management center. So if any violation have occurred, that it is able to send the information to the TMC center, where TMC can basically send some sort of challan or warning to that vehicle, saying that there is a violation of the road at that period of junction. So now coming to incident management system. So this incident management system is very much important because it rapidly detect and verify response and the clearance of traffic incident such as accidents, vehicle breakdowns and hazardous situation. If such type of situation arises onto the road, then this type of management system is very important. So the major component include the automatic incident detection, which is AID, using cameras as well as centers, where the monitoring control is being taken by the traffic management centers, the emergency response coordination, traveler information system, then efficient incident management, so which minimizes the secondary crashes, that reduces delay and improves reliability of the transport networks. So basically in this incident management system, we are able to see if any sort of incident have happened on the road, if so it had happened, how to overcome it. So by using some sort of cameras or centers, and then the information is being sent to the traffic management centers, where some coordination is taken place, and we are getting that information such that we can also minimize different types of crashes, reduce the travel time, which is nothing but the delay, and finally it leads to the reliability of the transportation network. So this is how the ITS works, intelligent transportation system, where different type of vehicle incident detection can be done using the cameras and sensors which are mounted to the nearby vantage point, okay, near the roads. Next, let us see what is ITS and sustainable mobility. So sustainable mobility, so in order to promote it, so ITS plays an important role by improving the efficiency of the existing structure and encouraging the environmental friendly travel behavior. So basically the things included in it is reduction in vehicle idling and stop and go traffic. So basically if the ITS is correctly being implemented onto the road, we can reduce the idling time of the vehicles, such that the fuel consumption also can be minimized, and the stop and go traffic in the sense the signal coordination can be very in proper position. And support for public transport and non-motorized transport. So as said, like India is having a heterogeneous type of traffic where motorized and non-motorized traffic totally ply in it. So a proper coordination between the public transportation and non-motorized vehicle is also essential in order to have a smooth flow of traffic on the roads. And then coming to ITS real-time information, which is enabling the efficient route choice. Then the emission monitoring and eco driving support. So we can also monitor the emissions or the pollutants which is coming from the tailpipe from the diesel vehicles and the petrol vehicles as well. So through these applications, a sustainable mobility can be achieved, where this ITS contribute to reducing the greenhouse gases. Like if you have a control over the emissions, we can also reduce the greenhouse emissions or the gases and the energy consumption. So coming to the computational technologies which is being used in the ITS. So basically the recent advances in the vehicle electronics has moved it to the fewer more capable of computer processing on a vehicle. So a typical vehicle in the early 2000s, which will have between 20 and 100 individual network microcontroller or the programmable logic modulars with non-real-time operating system. So basically in the 2000s, there were so many type of processors is being installed on the vehicles, and they are more costly because it is having more hardware memory management, and then it was helping the real-time operating system. But the new technologies, in the new computational technologies, in which the new embedded system platform have come, which has a sophisticated softwares which is being implemented such that the model-based processor control and the use of AI helps in computing. So it is basically the use of these type of ITS is artificial intelligence basically helps on reduce the load on different types of electronics which were previously being installed on the computers, so that we are able to now give it a sophisticated software application such that the computational technologies is very much easier with the help of use of AI ML in the intelligent transportation system, rather than moving to a large computer process which were being installed in the 2000s. So this is how the connectivity look like. So we can see that this is a TMC where the traffic management centers, where everything has been will be recorded, and here different types of cameras can be placed, like CCTV cameras, the sensors, the infrared rays can be helpful for monitoring the traffic on the road, and we can see how the smooth flow of the traffic is there without any lane changing behavior as well. Next, let us see what is a floating car data or the floating cellular data. So basically, what is this floating car? So floating car is nothing but a probe vehicle which is used for data collection. So what type of data? So it is a relatively low cost method for obtaining the travel time and speed data. So basically in this floating car method, we are able to obtain the travel time and speed data. So what is the travel time from location A to location B, and at what speed the vehicle is moving on the streets, highways, freeways and other basically roads. So broadly speaking, three methods has been used to find out the raw data. Okay, so this is how it look like. So this is nothing but a floating car method where we are able to see how the car is moving in different routes, and what speed we can maintain, so that we can see in this floating car technique. Then we can see like different applications, like different things, like a Wi-Fi sensors or the Bluetooth sensors can be used in order to find out what is the travel time from moving from origin to the destination. So in this, basically the floating car method, the triangulation method we are using. So basically, what is this triangulation method? It is nothing but in the developed countries, a high proportion of car contain one or more mobile phones. So basically, these transmit the information to mobile network such that no voice connection is established. So basically, when a car moves, the signal of the mobile phones that are inside the vehicle also measures. So then we are able to measure and analyze what is the network data using the triangulation. So this is how the triangulation look like, where we are able to establish a connection from vehicle to vehicle. So by measuring this type of triangulation, we are able to convert that data into the traffic flow information. So basically, if we get the data of this triangulation method, we are able to find out what is the flow of the traffic. Flow in the sense, what is the number of vehicles which are plying on that road. So this method is very much advantageous, okay, and basically it doesn't require need to build along the road, so only the mobile network is leveraged. So in this we are not focusing on the infrastructure, we are only focusing on the basically the phone networks, the mobile phone networks, where a triangulation has been established from one vehicle to the another vehicle, wherein which we are able to collect some sort of data like the traffic flow data. But basically in practice this triangulation method can be complicated. So it is bit complicated, especially in the areas where same mobile phone towers or two or more parallel routes, such that a road geometry, a frontage road, a motorway or commuter rail line, so in the parallel streets, so it is a bit complicated, especially in the areas which is having the mobile towers which is serving two or more parallel routes. So it forms a little bit complication at that type of road. So then different technologies can be adopted, where different sensing technologies or the cameras or the infrared cameras can be used, where where a connection is built between one vehicle to the another vehicle. So then we can go for the vehicle re-identification. So what is this method? So it is using a set of detectors. So there are detectors which are mounted along the road. So in this technique, a unique serial number for each device in the vehicle is detected at one location and then detected, that is nothing but re-identify. That is why it is called as vehicle re-identification, which furthers down to the road. So the travel times, so basically in this vehicle re-identification, we are also calculating the travel times and the speed by comparing the time at which the specific device is detected by the pair of sensors. So basically this we can pair, or we can see how is by using the MAC address which is coming from the Bluetooth or the other devices, okay, which is from the RFID serial numbers, which is basically used in the electronic toll collection in the toll plazas, where we are using the transponders, so which is also called as toll tags. So this is vehicle re-identification, where we are able to find out the unique serial number for a device such that it is detecting again, and the travel time and the speed is being calculated by this method. So again this is again vehicle re-identification. Next, coming to GPS methods. So GPS methods, basically we are using the help of satellites to get some sort of information about the roads. So GPS based methods, so an increasing number of vehicles are basically equipped with in vehicles like nothing but the satellite navigation system, which is having two-way communication with a traffic data provider. So the position, so basically here we are getting the GPS related information, what is the lat and long position of the vehicle on the road. So the latitude and longitudinal position basically are used to compute the vehicle speeds. Then coming to the modern methods, which may not be used dedicated hardware, but they are using the smartphone based solution, which is called as telematics 2.0 approaches. So again we are moving from the modern methods, so basically they are not using a complex type of hardware, but instead we are using the smartphone which is having some sort of solution, which are basically called as telematics approaches. So this is a GPS based methods, where we are able to find out what is the lat long position of the vehicle. So this is how the GPS methods look like. Coming to smartphone based rich monitoring. So what is a smartphone based rich monitoring? So it is having different types of sensors, where we are able to track the traffic stream characteristics like the speed, density, flow and all. So what is the accelerometer data we are getting from the smartphone from the car drivers is basically monitored to find out what is the traffic speed and road quality. So the audio data and GPS tracking. So we are using two type of combination over here, where the audio data and GPS tracking of the smartphones enables the identification of traffic densities and possible traffic jams. So next, coming to sensing technologies. So what is a sensing technology? Sensing, the word itself says that it is sensing something to get information. So the sensing technology is nothing but the technological advancement in the telecommunications and information technologies, which is coupled with different ultra model art, that is the microchips or the RFID, which is nothing but the radio frequency identification, and inexpensive ITS, that is intelligent beacon using sensing technologies, have different technical capabilities which will facilitate the motorist safety benefits or the intelligent transportation system globally. So basically this sensing technologies, so what are this? So these are nothing but the vehicle and infrastructure based network system. So it means what? The intelligent vehicle technologies, so where infrastructure sensors, basically the reflector devices, were able to install or embedded on the road surrounding, such that the buildings or post or signs as required and may be manually disseminated during the preventive road construction and maintenance by sensor injection machinery for rapid deployment. So basically what is the sensing technology? So sensing technology, we are able to sense the data, we are able to collect the data by different technologies, like it is coupled with the telecommunications or RFID or something relevant parameters where we are able to get the information. So these here there are two types of sensing technology. One is intrusive, the other one is extrinsic. Intrusive is basically the connection we are able to place on the surface of the road, where we are able to get the information if the vehicle is passing onto the road. And extensive is nothing but it is not embedded on the surface or beneath on the road, but it is there near to the road or near the edge of the road, such that we are able to capture the information or take the information from that. So best example of the extensive is nothing but the CCTV cameras or different type of cameras or sensors which has been deployed near the road. So this is how the sensing technologies look like. Next, so what is vehicles? So basically when we are seeing the vehicle sensing systems, which include the deployment of infrastructure to vehicle and vehicle to vehicle infrastructure. So here different types of sensing technologies were able to build the connections, that is nothing but I2V, infrastructure to vehicle, vehicle to infrastructure, that is electronic beacons for identification communication, and then we are able to deploy the video automatic number plate recognition or the different magnetic signatures detection technologies, or design intervals for sustained monitoring of the vehicles which are operating in the critical zones. So basically we are taking the help of some sorts of sensors, which is RFID or different type of sensing cameras, so where we are able to build different connections onto the road, such that we can detect something on the road, like basically so here we are able to detect the sensors, so that is called the vehicle detection sensor. If the pedestrian is there, then the pedestrian detection sensors. So different wireless devices we are using on the road for the sensing technologies. So this is how about the sensing technologies. About the inductive loop we will be seeing in the next class.